Right, so here is a question on Poisson distribution. So message arrives at a switchboard in a Poisson manner at an average rate of 6 per hour. So they gave it follows Poisson distribution in a Poisson manner. So find the probability for each of the following events. Exactly 2 messages arrive within 1 hour. No message arrives within 1 hour. At least 3 messages arrives within 1 hour. So now you can define your random variable x. X represents the number of messages arrived in 1 hour. So this is what your random variable x, and here it clearly given that x follows Poisson distribution with parameter lambda. So what is lambda here? If you observe that at an average rate of 6 per hour. So now here average of a Poisson distribution, that's what lambda itself, that's what n into p, which is nothing but lambda. So here lambda is given, the mean is given. So mean is 6, that's what they are saying. Average rate of 6 per hour. It means lambda is equal to 6. So it is clear that x follows Poisson distribution with parameter 6. So if you look at the first question, exactly 2 messages arrive within 1 hour. It means what is the probability that x is equal to 2? And you know formula for Poisson distribution. So this is e power minus lambda, lambda is 6, into lambda power 2 by 2 factorial. That's it. This is what you need to calculate. So you'll have 36, and this is 18 into e power minus 16. So this you need to calculate. Okay. And next b, what is the probability that x equal to no message arrives within 1 hour? It means number of messages arrived are 0. So this is e power minus 6 into 6 power 0 by 0 factorial. That's what sorry, why did I write 16 here? This must be 6. Okay, so this is e power minus 6. That's it. So 1 upon e power 6. This is the answer. And you use calculator and write what is the final answer. Okay. So the next C, at least 3 messages arrives within 1 hour. At least 3 messages. It means either 3 or more than 3. It means x is greater than or equal to 3. So you know how to calculate it. This is what 1 minus probability that x is strictly less than 3. And this is what 1 minus of x can be equal to 0 plus probability that x is equal to 1 plus probability that x is equal to 2. And we don't include 3 this time. Why? Because here you have greater than or equal to, so this side you'll get strictly less than. And you know what is it? 1 minus e power minus 6 is common for all. So probability that x equal to 0, if you remove this you'll have 1 plus you'll have 6 power 1 plus you'll have 6 square by 2 factorial. Okay, so you'll have 1 minus this will be 18, 24, 25. So 25 into e power minus 6. So this is the probability that x greater than or equal to 3. Okay, so this is how we can simply calculate. They gave it as Poisson distribution, so nothing to worry. You know the distribution and you know the formula. That's it. Now let us look at one more. So in a book of 520 pages, 390 typographical errors occurs. Assuming Poisson law for the number of errors per page, find the probability that a random sample of 5 pages will contain no error. Even though they don't give it follows Poisson typographical error, we'll take Poisson distribution only. Okay, anyway, they gave it here and they are giving some information. In a book of 520 pages, 390 typographical errors occurs. So if you want to see average number of errors, so what they will be? Total pages you divide, the total errors and divide with all page numbers, so that you'll get average number of errors per page. Okay, so first of all, let us define our random variable. So here the random variable x, this is defined to be number of errors per page. So this is what x, our random variable, says. And here it is given that x follows Poisson distribution with parameter lambda. And let's see what is lambda here. That is what average number of errors per page. And how do you calculate? Total errors by total number of pages. So this is what will give you average number of errors per page. So this is what the numerator given 390 and it is 520, isn't it? So this is what 39 by 52. So this is equal to 3 by 4. So this is what lambda. Now we got lambda equal to 3 by 4. So now what is it they're asking? Find the probability that random sample of 5 pages will contain no error. So you are actually taking 5 pages. First, let me do one thing. Let me calculate it for one page. If you take one page, the probability that it's not going to have any error, that is probability that x equal to 0. So this is equal to e power minus lambda into lambda power 0 by 0 factorial. That's what e power minus lambda itself. Now this is what e power minus 3 by 4. But what is it they're asking? See, this is for one page, but they are taking 5 pages. So when you take 5 pages, so now they are independent. The number of errors in the one page is independent of number of errors in the second page. Okay. So when they are independent, what you can do is you can simply multiply one after another. So probability that x equal to 0 whole power 5, which is equal to e power minus 3 by 4 whole power 5. So in other words, this many number of errors you can have. E power minus 15 by 4. So if you take 5 pages, this many number of errors. This is the probability that no page will contain an error. Okay. Next. So here is a problem. In a precision bombing attack, there is a 50% chance that any bomb will strike the target. So 2 direct hits are required to destroy the target completely. How many bombs must be dropped to give a 99% chance or better of completely destroying the target? So how our random experiment is to attack the target. Okay, so now you can define your random variable. So the random variable, my x represents number of successful hits. or simply you can take it as number of hits to the target. Okay, so here 2 direct hits are required to destroy the target. It means if x equal to 2, then target will be destroyed. And even you can have more, even x equal to 3, 4, from 2 itself it will be destroyed. So now probability of getting success. What is the probability of getting success here? They gave it is 50% chance that one bomb will strike the target. So probability of getting success here is 1 by 2. This is equal to 1 by 2 because they gave 50% chance. Now what is the exact question? How many bombs must be dropped to give 99% chance or better of completely destroying the target? Try to understand the question here. So this is what we require, probability that x greater than or equal to 2. If x equal to 2 or greater than 2, we know that the target will be destroyed completely. Okay, so probability that x greater than or equal to 2, we want this to be 0.99. Now the question is how many bombs need to be dropped. See, try to observe one thing. X does not represent the number of bombs dropped, which actually represents the number of successful hits. So here you can see which distribution x follows. It is clear that x follows binomial distribution with parameters n comma p, where we know the probability of getting success, we know it is 1 by 2. But what is n? Now that's what exactly they're asking. So what is this n so that this probability is equal to 0.99? It means how many bombs you need to drop. What must be this n? So that's what they're asking. Is it enough to drop 2 bombs or 3 or 4 or 5? What is that number? So you need to take that number in such a way that this probability is exactly equal to 0.99. Okay, so let us try to find it. We don't know what is n, but we know x follows binomial distribution with parameters n comma 1 by 2. So let us calculate what is this. This one can be written as 1 minus probability that x is strictly less than 2, which is equal to 0.99. It means 1 minus probability that x equal to 0 minus probability that x is equal to 1, which is equal to 0.99. Right? So this is 1 minus n choose 0 into, where p is 1 by 2, into 1 by 2 whole power n, minus n choose 1 into 1 by 2 into 1 by 2 whole power n minus 1. So this is equal to 0.99. Okay, so now this is 1 minus n choose 0, that is anyway 1. So what you have is 1 by 2 power n minus n choose 1 is n, so n by 2 power n. So that's equal to 0.99. So this is the expression, you have it here, sir. 1 minus 1 by 2 power n minus n by 2 power n. This we wanted to be 0.99. So now the question is, what is n? See here, maybe solving for n, it might be a little difficult task. So instead of solving, what you can do is, you can simply substitute. For example, if I take n equal to 5, am I getting this 0.99 or more? Can you calculate and tell me what is 1 by 2 power 5 minus 5 by 2 power 5? It means you need to calculate what is 1 minus, of course you can write it as a single number. So let me write this like this, 1 minus of When you take minus common, you'll have 1 plus n by 2 power n. So when n equal to 5, it means you need to see 1 minus 6 by 32. What is it? Okay, you are saying it is around 0.8, so n equal to 5 doesn't work. So what happens if I take n equal to 10? If I take n equal to 10, then I get 1 minus 11 divided by, you get 2 power 10. And what is it? 0.989. Okay, you're saying it is 0.989. Still we are not at this. So let me do one thing. What happens if I take n equal to 11? Just one more. It means 1 minus 12 by 2 power 11. I hope this will be more than 0.99.
0.994, sir.
Yeah. So it is 0.994. If you round it, it is exactly 0.99. Therefore, we can say that n equal to 11. Therefore, answer to this question. So how many bombs must be dropped to give this 99% accuracy? So 11 bombs must be dropped so that I am 99% sure that the target is destroyed. Okay, see, if you drop only 5 number of bombs, you can see how much percentage we are sure. Only 81% we are sure that the target was destroyed. But if you drop 11 number of bombs, 99%, it means almost sure that the target was destroyed. Okay. Yeah. So now there is an interesting problem here. 6 coins are tossed 6,400 times. Using Poisson distribution, find approximate number of getting 6 heads 2 times. So all that you need to define your random variable first. What is your random variable? 6 coins are tossed. Using Poisson distribution, find the approximate probability of getting 6 heads 2 times. Now getting 6 heads, we'll take it as a success. Okay, so now x represents number of 6 heads. See, 6 coins are tossed, no? So when you toss 6 coins, you can have outcomes like this: tail, head, head, tail, tail, tail. Okay, suppose if all coins shows head, it means all 6 coins shows head, I'll term it as a success. Okay, so that's what I mean. Number of 6 heads occurred. Or in other words, number of success. Success, I mean all coins shows up heads. That's what. So now it is clear that x follows binomial distribution with parameter 6,400. Why? Because this many number of times I'm tossing that coin, tossing the 6 coins. So 6,400. And what is the probability of getting success? So when you toss 6 coins, there will be 2 power 6 outcomes. And how many favorable outcomes are there? There is exactly one favorable outcome, that is all heads. So now the probability of getting success, P, is 1 out of 2 power 6. That is 1 by 2 power 6. So now x follows binomial distribution with parameters 6,400, 1 by 64. Now let's see what is its mean, that is the expected value, that is n into p, that is 6,400 by 64. So this is what exactly 100. Now since n is large and p is small, you can take Poisson distribution, and of course they are asking us to use Poisson distribution here. So now x follows Poisson distribution with parameter lambda, where lambda is equal to 100, that is mean. That's it. Now what is it they are asking? Find the approximate probability of getting 6 heads 2 times. It means what is the probability that x is equal to 2? Yeah, we know this is what e power minus lambda into lambda square by 2 factorial. So this is what e power minus this is 100 whole square by 2. So this is what we need to calculate. So this will give you the approximate probability that getting 6 heads 2 times. Okay. Now let us look at another interesting question. So find the probability that a person tossing 3 coins will get either all heads or all tails for the second time on the 5th toss. Say a person is tossing 3 coins, and what is it we required is either all heads or all tails. So the required outcome is this: either we want all heads or all tails. So if you get all heads or all tails, this is what we term it as a success. Okay, success, it means getting either all heads or all tails. So here they're asking what is the probability that this success will occur for the second time on the 5th toss. It means when I toss it once, when I perform this random experiment once, first time I got something, second time something, second time, third time something, and fourth time, and 5th time, this must be at the 5th place. It means on the 5th trial, you must have second success. Okay, and first success, it may occur in any one of the first 4 places. So what I need is, in the 5th trial, I need the second success. So what is this probability? Okay, so to answer this question, we should know one distribution before it. That is, see, so far we are seeing the number of if when you perform n trials, we are looking at the number of success. That's what we are calling binomial. In binomial distribution, what we are doing is we are looking at x represents number of success in n trials. Okay, so but this time what we are looking is number of trials to get rth success. Number of trials to get rth success. So it is opposite of this. So that's why we are going to call it as a negative binomial random variable. Negative binomial random variable. Number of trials to get rth success. Or in other words, if r equal to 1, and the number of trials to get the first success or the second success. So if you observe this question, this exactly represents what is the probability that the 5th toss will give you the second success. It means if you take that x is equal to 5. So 5th toss should give me the second success. Anyway, let me explain here completely. So if you take x represents the number of trials to get r success, so let us find what is the probability density function for it. So before that, can you tell me what are the possible values of x? Possible values of x. Suppose if I take r equal to 10, if my r is 10, can this x take 0, 1, 2? Is it possible? Hello? See, I am performing a random experiment, a Bernoulli trial. Okay, in that Bernoulli trial, either you will get a success or failure. Now my interest is to see the number of trials required to get rth success. అంటే నాకు 10 సక్సెస్లు కావాలమ్మా, 10 సక్సెస్లు కావాలంటే ఎన్ని ట్రయల్స్ పర్ఫామ్ చేసే అన్నది ఎక్స్ కౌంట్ చేస్తుంది. సో మీకు 10 సక్సెస్ కావాలంటే ఎన్నిసార్లు ట్రయల్ చేయాలి? కంపల్సరీ 2 సార్లు ట్రయల్ చేస్తే మనకు 10 సక్సెస్లు వస్తాయా?
No, sir.
Okay, tell me then what are the possible values of x? So x cannot take 0, that's for sure. X cannot take 1, x cannot take 2. So what are the possible values of x?
Greater than or equal to 10. Sir.
Exactly. So x can be 10, 11, 12, 13 and so on. There is no end. So if you want 10 success, definitely you should perform 10 trials. 10 or more. It may happen that all 10 trials will give you the success only. In that case 10 is enough. If not 11, if not 12, if not 13. And that way it can go till any point. Okay, so the possible values of x are 10, 11, 12 and all. So if you take r success, then the possible values of x are r plus 1, r plus 2, r plus 3 and so on. Okay, so now the question is, what is the probability mass function for it? See, it is clear that negative binomial distribution, it is a discrete distribution. Why? Because it takes countably many values. So it is a discrete distribution. Now the question is, what is the probability mass function? So first let me see, what is the probability that x is equal to r? Suppose if you want r success, and let me assume that probability of getting success is p. Let me have this assumption. Probability of getting success is p. Okay, so you are performing r trials. In all r trials you want r success, so therefore the probability of getting success is p. So for the first success it is p, second, third and so on, p, total r. So this is p power r only, that's it. Now the next thing, what is the probability that x is equal to r plus 10? It means when you perform, you need to perform r plus 10 trials to get r success. Or in other words, r plus 10th place lo meeku rth success akkada avvalandi. Okay, let me do one thing to avoid confusion. Let me assume r equal to 10 for time being. Okay, I am taking r equal to 10. So if I take r equal to 10 here, so probability that x is equal to 10, which is exactly, each trial we want success. So there will be 10 number of success, so p power 10, that's it. So next, what is the probability that x is equal to 19? అంటే 19th ట్రయల్లో 10th సక్సెస్ అక్కర్ అవ్వాలి. ఇక్కడ x ఏం కౌంట్ చేస్తుందంటే నెంబర్ ఆఫ్ ట్రయల్స్ పర్ఫార్మెడ్ సార్, నెంబర్ ఆఫ్ ట్రయల్స్ టు గెట్ ఆర్త్ సక్సెస్. అంటే లాస్ట్ ట్రయల్లో ఆర్త్ సక్సెస్ అక్కర్ అయిందని. మనకి ఇక్కడ ఎన్ని సక్సెస్ కావాలి? 10 సక్సెస్ కావాలి. ఎన్ని ట్రయల్స్ పర్ఫామ్ చేయాలనుకుంటున్నాను, 19 ట్రయల్స్ పర్ఫామ్ చేయాలి, దాంట్లో ఖచ్చితంగా 10 సక్సెస్ రావాలి. అంటే ఇప్పుడు 19th ట్రయల్లో 10th సక్సెస్ వచ్చింది, అప్పుడు మనం ఎక్స్పెరిమెంట్ ఆపేస్తాం. సో యూ కెన్ కౌంట్ ఇట్ దిస్ వే, 1 2 3 and so on up to 19. Okay, so on the 19th place we need the 10th success. 19th ప్లేస్లో ఖచ్చితంగా 10th సక్సెస్ రావాలి, అప్పుడే నేను 19th ట్రయల్స్తో ఆపేస్తాను, ఎందుకంటే నాకు కావాల్సిన 10 సక్సెస్ ఇక్కడ. ఓకే, సో ఈ 19th ప్లేస్కి ముందు ఎన్ని ఉన్నాయండి, 18 ప్లేసెస్ ఉన్నాయి. Now all these in all these 18 places we want to adjust 9 success. ఎందుకంటే 10th సక్సెస్ 19th ప్లేస్లో ఉందంటే బిఫోర్ దట్ you'll have 9 success, right? Now you need to adjust these 9 success in these places. So you do one thing, out of these 18 places you choose 9 places to keep this success. So what I'll do is 19 minus 1 choose 10 minus 1. So in these places I'll keep the success. Okay, so this many number of possibilities are there. Okay, into how many success are occurred here, total 10 success are occurred, so p power 10 into how many failures are occurred. You performed 19 trials, if 10 success are occurred, then definitely 19 minus 10 number of failures are occurred. So this is the probability mass function for negative binomial random variable. Okay, and here we say that x follows negative binomial distribution. We denote with NB with parameters r comma p. Okay, so here x actually represents number of trials until the rth success occurs, or better if I write it this way. So number of trials until rth success occurs, and the moment rth success occurs we'll stop our experiment. Okay, so now let me write it, probability that x is equal to n. So if you want rth success in the nth trial, then what do you do? First, so in the nth place you want rth success, and before that there are n minus 1 places. In these n minus 1 places you choose r minus 1 places to keep this success into, and the total number of success occurred are r, and the total number of failures which are occurred are n minus r. So this is the probability mass function for a negative binomial distribution. So be careful. X represents the number of trials until rth success occur. So let me write it here. If x follows negative binomial distribution with parameters r comma p, what x represents here? X represents number of trials performed until rth success occur. Okay, so this is what x represents. Now the probability mass function, so the probability that x is equal to n, which is equal to n minus 1 choose r minus 1 into p power r into 1 minus p whole power n minus r. Okay, so now let us answer this question. Find the probability that a person tossing 3 coins will get either all heads or all tails for the second time on the fifth toss. So on the fifth trial, we want the second success. It means how many number of success we want? We want 2 success. Therefore, R is equal to 2. And what is the probability of getting success here? See, you are tossing a coin for 3 times. Either you want all heads or all tails. So therefore, the probability of getting success, 2 favorable outcomes out of 2 power 3 outcomes. So therefore, this is 1 by 4. So the probability of getting success is 1 by 4. So now let me define my random variable. So my random variable represents number of trials to get second success. What is a success here? Success, it means getting either all tails all heads or all tails. So this is what we mean by a success here. Okay, so we want on fifth toss, we want to obtain the second success. It means probability that x is equal to 5. This is what they're asking. So let's find. So probability that x is equal to 5, which is nothing but 5 minus 1. Choose what is r here. R is 2 because we want 2 success. So 2 minus 1 into p. What is probability of getting success? Which is 1 by 4. So 1 by 4 whole power 2. This is 1 minus 1 by 4 whole power 5 minus 2. So this is what exactly 4 choose 1 into 1 by 4 whole square into 3 by 4 whole cube. I hope you can calculate it. This is 4 choose 1 is 4 and you can cancel it. So 1 by 4 and this is 27 by 64. So 27 by 256. So this is the probability that you'll get either all heads or all tails for the second time on the fifth toss. Okay. Now let us look at one more interesting problem. If the probability is 0.4 that a child exposed to a certain contagious disease will catch it, what is the probability that the 10th child exposed to the disease will be thought to catch it? So probability is 0.4 that a child exposed to a certain contagious disease will catch it. It means it's a kind of the situation what we faced earlier, coronavirus, right? Once if you visit a person who has coronavirus, what is the probability that you get that virus? If there is no mask and all, that probability is actually 0.999 you can take. But let's assume you have taken precautions, but still there is a chance, right? Let's assume that chance is 0.4. Okay, so now there is this patient, like let's say there is this disease with some guy. Okay, now there are visitors to this person, 1, 2, 3, 4, like there are 10 visitors, let us assume. So what these visitors are doing is, like these people will go to this guy and they'll just talk with him and they'll come back. That's what they'll do, let's assume. Okay, so now the question is, what is the probability that the 10th child, it means this here is the 10th child exposed to the disease, will be the third to catch it. It means third person to catch the disease. It means before this 10th person, 2 people have already got the disease. That's what it means. So here, probability that he is going to get the disease is 0.4. And you define your random variable. X represents. How do you define your X? There we say that number of trials to obtain our success. So X, you can take it as number of exposed persons to the disease, so that until you get three successful people to catch the disease. Okay, I hope you understood what is X. I'm not writing here. So here, what is it we need is X. You can see it follows by negative binomial distribution with parameters 3, probability of getting success is 0.4. Okay, now the question is, what is the probability that X is equal to 10? It means 10th person exposed to the disease will be the third one to catch the disease. So it is easy to calculate. Probability that X equal to 10 is 10 minus 1, choose 3 minus 1 into P power, that is 0.4 whole power 3 into 1 minus 0.4 whole power 10 minus 3. So that's what 9, choose 2, 0.4 whole power 3 into 0.6 whole power 7. Yeah, so this is what you need to calculate and write the final answer. I'd like to know the probability here. Please calculate and let me know. Is that what you get? 0.064?
Yes, sir.
So there is only 6% chance that the probability that the 10th child exposed to the disease will be the third to catch it. That will be only 6%, and the chance is 0.06. Okay, so the problems on negative binomial random variable will be interesting problems like this. Okay, so suppose if r equal to 1, suppose if this r equal to 1, it means if X represents number of trials until the first success occurs. Number of trials to get the first success. Or the number of trials required to obtain a first success. So that's what X represents. So now we call X follows geometric distribution. So there is nothing in a negative binomial distribution. When r equal to 1, we call it as a geometric distribution. Why? Because if you look at its probability distribution function, that looks like the terms in the geometric progression. So that is why it is called geometric distribution. So let me write what is probability that X is equal to n. See here, r equal to 1. So when r is 1, so this is exactly p power 1 into 1 minus p whole power n minus 1. Okay, it's looking like a into r power n minus 1. The terms are looking like the terms in the geometric progression. Okay, so that is why this distribution is called geometric distribution. So negative binomial distribution is called geometric when r equal to 1. Okay, so we have to discuss what is the expected value of a negative binomial distribution. So what will be the expected value and what will be the variance of X? These are the things we need to calculate. Okay, so take them as homework and try to finish it. So expected value will be r into 1 by p. That's what r by p. Okay, so whereas For a geometric distribution, it will be 1 by p only. Anyway, you take them as homework and try to finish it. Okay, so this is about discrete distributions, and we have one more distribution called hypergeometric distribution. That anyway I'll discuss in the next class. Okay, so I'll stop it here and let me know if you have any questions or doubts.